Hey friends, I hope you are all doing great, and today we are going to write a program in C language that will take an integer from user and the output will show whether the number is prime number or not. So let's get started. Here is our main function, and inside that we are going to write that simple program, and let's declare a variable named n to store that number, and simply a printf enter a number, and then a scanf to scan that number, comma address of n, and then we are going to use a for loop to check that number is a prime number or not. And for that for loop we need another variable named I, so declare it there, and then start your for loop is equal to 2. So now we're using starting I from 2 because obviously every number will be divided by 1, so we don't need to check the number is divided by 1 or not. So we're starting I from 2, and then I less than that number, and then I plus plus, and then that our body of for loop, and inside that for loop we need a if to check the remainder, and for that we are going to use modular division condition here. And now write n modular divided by I is equal to 0. That means n evenly divided by I. If that is true, then we are going to use a flag here, and flag initially is 0, and if the number is divided by 1, then flag is going to be 1. And that's all. And then we are going to again check the value of flag is equal to 1. If flag is 1, then the number is not prime number because it is obviously divided somewhere in this I in this loop. So we'll say that %d is not a prime number, and %d is our n, that number, and else we're going to print that same kind of printf. So copy it and paste it here, and this time we're going to say %d is a prime number, and that's all. Let's compile it and run it, and give an integer that is 10. So it is saying 10 is not a prime number. That's absolutely right. And let's run it once again, and let's put an integer which is a prime number, let's say 23. So 23 is a prime number, so it is also right. I think it's working. So now what you can do is let's reduce that number of iterations here, because we don't really need that much of iterations to check a number is prime or not, because we can make it better now, efficient. So we can check just up to the half of that number, that is n. So we can just change that condition by half. We can reduce that number of iterations by 2 now. So it will rotate now it will rotate really less time than that it was rotating previously. Let's run it once again. So if you run it, it will give the same kind of output. It doesn't make any difference in that output screen, but it is efficient than the previous one. So now you can make it more efficient by using another function here. For that we need to include a header file, that is math.h, and what you can do is use that square root function, square root of n, and pay attention that I am saying that up to that square root of that number, that is less than equal to, not only less than. So you can google it that why I am using this condition here, because if the number is a prime number, it will obviously have a evenly divisor in between that, in between 1 up to square root of that number. There is going to be a divisor of that number in between this range. So let's run it once again. It is still working fine, I think. So 23 is a prime number, that's right. And let's put something bigger. So obviously 115 is not going to be a prime number. It is obviously divided by 5, I know that. So that's all. Hope you enjoyed this video. See you next time. Hey friends, I am back just to share with you another piece of information which is going to make your program more efficient. That is this break statement here. Just because you are giving this break statement here, it's going to make your program more efficient. So that's all. That's working fine still, but it's going to make your program more efficient in case of bigger numbers like a million. When your input is a million number, then it's going to be a better choice to put a break here. So that's all. See you next time.